Big one. Space. The final frontier. It's really big. Like really, really, really big. But even though it's really big, we're not going into space. We're diving into the building block of all living things and non-living things. The atom. Throughout noontime, people have been trying to dissect what really is inside atoms, but their science has made it almost impossible to. Multiple theories have been developed in the hopes of making sense of what goes on inside these strange things, but only until recently have we been able to get a glimpse inside of an atom. Here to help us with this foreign world is lead scientist of the Hopewell Valley Particle Research Project, Jonny.
Thank you for having me on the show, Jack.
Thank you. Wait, where's Jonny? Oh, there's Jonny.
I'm here.
Yeah, that's weird.
I know.
How'd you do that?
Atomic.
Whoa. Okay, you see that? Look in front of the camera. See, there are people there.
Hi, people.
Yeah, you know.
I'm here to help explain to you the atom.
So what are you gonna say, Jonny?
Well, it all started with a really old man, a really long time ago, named Democritus. More than 2,000 years ago, precisely in 400 BC. He and his mentor, Lapisia, I don't even know, Latin, it's crazy, came up with a theory. The universe is composed of two elements, the atoms and the void that they exist in.
He pretty much hypothesized that atoms could not be destroyed. They differed in size, shape, and temperature. They also move and are invisible. He also thought that there is an infinite amount of atoms in the known universe.
So this created the first atomic model. It was a simple round shape that had no electrons, protons, or neutrons. This model began to help people understand the structure of an atom.
He suggested that all matter was formed from different types of tiny particles. The properties of these particles determine the properties of the matter.
His theories, however, did not stick around for a long time, since there were no known methods at the time to be used to prove his theory, since the microscope wasn't anywhere invented.
It was pretty much only until the 19th century when his hypothesis was reestablished to prove some laws that had already been established.
It would take almost 2,000 years until the next theory would be established by John Dalton.
His theory went a little like this. Everything in the universe is made up of atoms. These atoms are indivisible and indestructible.
All the atoms of a given element are identical in their mass and properties.
Compounds are formed by a combination of 1, 2, or 3, or even more atoms.
And finally, a chemical reaction is a rearrangement of the atoms.
You've probably heard these theories in school. More than 200 years after Dalton created the theories, many still play true today.
Though Democritus' theory was the beginning of the atomic theory, it was incredibly vague in how it described an atom.
But it was the first.
That's right, and even though he wasn't the first, Dalton's theory wasn't 100% correct.
That is true. Thanks to the theories that came after Dalton's, we know that the atom, in fact, is not indestructible. Atoms can be destroyed with the use of nuclear reactions.
We also know that within an element, there are different atoms that differ in their mass. These are also known as isotopes.
Though isotopes have different masses, they contain the same chemical properties of the element they are derived from.
Despite these things, some parts of his theory still remain true.
Which basically means that we still use and follow them today.
So you've been hearing about these things called atoms for a while now, but you also probably heard about something about what makes up atoms.
That's right. Even in this low-budget CHS production, you've heard us talk about protons, neutrons, and electrons.
But where did these things come from, Jack?
Well, I don't know, but it all started with a British guy named J.J. Thomson. During a series of experiments, he managed to discover that the first of the 3 subatomic particles of an atom, the electron.
Oh yeah, that was the guy who used a crooks.
What in the world is a crooks?
A crooks, spelled C-R-O-O-K-E-S, is otherwise known as a cathode ray tube, which contains negatively charged cathode rays.
So he also studied the positive particles in the neon gas, right?
Correct. From this, he realizes that the model that the scientists have been using for years did not show any of the negative or positive particles in the atom.
So he did what almost every scientist does. He made a new model and used plum pudding, because that's what everybody does. And
Sounds pretty good.
yeah, it's really good. I mean, I haven't tried it, but I heard it's like a staple in England.
Mm-hmm.
Yeah. He proposed that the raisins in the pudding represented the negative particles, otherwise known as electrons, while the dough represented the positive particles.
So he discovered both the electron and the proton.
Kind of, but he really didn't. The model did manage to show some of the electrical properties of an atom, like the electron, but it did not recognize the positive charged particles as we know as protons. Johnny! Johnny, where you at, Johnny? Did you shrink down to an electron? Where you at, Johnny? I don't know where you are.
Very funny, I'm right here.
Oh, you're right there. That's Johnny. Woo! So we know how the electron came into knowledge, but what about the protons that Thomson managed to miss, or he kind of lost in his pudding?
The discovery of the proton came a few years later. A former student of J.J. Thomson named Ernest Rutherford, along with a team of fellow scientists, managed to discover what lies at the center of every atom.
Alright, so it's a pretty good story. I mean, they tell it pretty much to every 5-year-old now these days, because why not? But it pretty much goes like this. In 1911, Rutherford and a team of scientists were performing experiments using alpha particles.
That's the thing with the gold foil, right?
Yeah, it actually is. Right. He aimed the alpha particles at solid objects, like the gold foil, then recorded the places where the alpha particles passed through a sheet of fluorescent screen. You will never guess what happened.
What happened?
I don't really know, but I want you to guess.
Knowing atoms, did something explode?
Okay, don't guess. That was kind of chemistry, but no, nothing exploded. To the amazement of the scientists, most of the alpha particles passed through the screen, but some particles seemed to bounce off at an angle. These particles also shot straight back.
So this means that since the alpha particles are positive, that had to be something that deflected the particles.
That is completely true, Johnny. They concluded that an atom consists of a small but very dense positively charged core known as a nucleus. Using data from Thomson's experiment, he concluded that the nucleus needed to be positive, while the nucleus was surrounded by the negative electrons.
So he kind of proved Thomson wrong, but also managed to create a new model at the same time.
That is completely true. This new data formed the basic structure of an atom, a positive nucleus with protons on the inside, surrounded by, guess what, a cloud of negative electrons.
All you really need to know from this information is that this formed the most basic model of an atom. Up to that point in time, the model created by Rutherford and his team was the most accurate humans have managed to make the atom look like.
And it wouldn't be long until another scientist would take that model and give it a serious makeover. This makeover would take the lines between an actual atom and what we think it looks like, and reduce it to a thing that we know it today.
You've probably noticed a trend going on here. Every scientist after the previous scientist finds a way to make a new model, and you'll never guess what happens with our next scientist.
Do they keep the theory of the previous scientist?
No.
Random guess.
Go for it.
Does the new scientist, possibly a student of a previous one, make a new model?
Wow, how would you know that?
I don't know, random guess.
Oh, okay. In 1913, Niels Bohr, a student of Rutherford, created a new theory. Remember how I said that I wasn't going to talk about space?
Yeah, I do remember.
Well, I kind of lied. You know what a planetary orbit is, right?
Yeah, of course. It's, for the most part, every planet orbits its star, right?
Well, Bohr proposed that electrons in a concentric circular orbit around the nucleus.
So, like planets do, right?
Right. Bohr's model is now even known as the planetary model.
So, what do electrons have to do with orbits?
In the orbit around the nucleus, the electrons have certain orbits around the nucleus, kind of like planets. Each orbit also carries a certain energy with it. The electrons closest to the nucleus have energy of E1. The next is E2, E3, and so on.
But is it possible for an element to move from its orbit?
Yes. When an electron jumps from a higher to a lower orbit, energy is emitted. When energy goes from a lower to high orbit, energy is absorbed.
That is Pretty cool, everybody.
That's where the story of the atomic model ends. Of course, there are going to be more models in the future after these 5, but these are the most important as they show the history of the basic atomic theories.
That's pretty cool. These theories form the basis of what we know about the atom. Thanks to modern technology, we have been able to get even closer to what an atom is.
Now it's your turn. Use the provided scrap paper on your desk and draw your best representation of what Bohr model looks like.
Ready?
Science.
It's a wrap.
Wrap.
How long is that?
That was a while. That was like